So let's look at problem number 3. This is the speed trap. You've the brakes on your car are capable of slowing down your car at a rate of 5.2 meters per second squared. You're traveling at 137 kilometers per hour. You see a cop, radar guns pointing at you, and then the question is, what's the minimum time in which you can get your car under the 100 kilometer per hour speed limit? And you could go further below the speed limit and still be under the speed limit, but the minimum. This is why we're talking about the minimum time. The minimum time is when we're at that maximum speed to be under the speed limit. We can continue to slow down and be further below the speed limit, but what's the minimum time to get to a point where we're below the speed limit? So we got to set up a couple of things. First, we going to have a car over here, so I've got my initial velocity is going to be 137 kilometers per hour, and this that speed is 38.1 meters per second, 38.055555, but I'll store that in my calculator. My final velocity, my maximum final velocity, is going to be 100 kilometers per hour, and which we know is 27.8 meters per second, or 27.77777. Now, a couple things we've got to maybe take into consideration. If you remember when we had the car braking to try and miss the student, we established, or were given, that the typical reaction time is about 1.4 seconds. So we're going to be seeing this as well. We're going to see the cop. We're going to hit the brakes after we reacted. So we've got to deal with these distinct physical situations. So so we're going to have a reaction time where we're traveling at initial velocity. We're going to be braking for a bit, and then once we get under the speed limit, I guess we can relax or continue down to be on the safe side. But the minimum is to get to 100. So we're going to look at that. Well, let's establish some directions. Let's assume that we're going forward. So this is my direction over here. My initial velocity is in this direction. My final velocity is in this direction. So if I'm moving to the right and I'm slowing down, then I know that my acceleration must be to the left. And that acceleration we're given is 5.2 meters per second squared. And if we establish some directions, we'll say that this direction is positive, this direction is negative. That means that these two velocities are positive, my acceleration is negative. So now let's take a look at how this would be represented in these our graphical formats. So if we do our motion diagram, our initial velocity, we're going to have a period of time for that 1.4 seconds. We're going to be moving at the 38 meters per second, and then I'm going to start there. I'm going to slow down, slow down, slow down, and then I'm going to get to a point where during my braking time, I don't know what that number is yet, so this is our reaction time. This is our braking time. We're going to be slowing down, and then we assume that we're going to be going at that lower speed for whatever period of time. But I'm not going to worry about this, because once I'm below the speed limit, I'm below the speed limit. I'm no longer in a position where I'd worry about being caught for speeding. So I'm only going to consider the braking time that we have, plus the 1.4 seconds that we would take to react to seeing the radar gun. So we sort of look at it like this. From our position time curve, we're going to have an initial speed that's higher. We're going to slow for a bit, and then we're going to continue on with our lower speed. So the area again that we're concerned with is this is our braking time, and this is our reaction time, and we want to sort of have these all represent the same sort of motion. So in my velocity time curve, I'm going to be moving at a speed for the reaction time. I'm going to slow down for the braking time, and then we'll assume that I'm going to go at the speed limit afterwards. So, but again, the area that I'm going to concern myself with is the braking time, because I already know my reaction time, and we want to know the time it'll take to get to under the speed limit. So we're going to have, this is where it's going to get a little bit crazy. I'm going to have no acceleration at first because I'm moving in uniform motion. I'm going to jump down suddenly. I'm going to hit the brakes. There's going to be a sudden jump. I'm going to get to a negative acceleration, and then we'll assume that once I'm under the speed limit, I'm going to go back to zero acceleration. I'll be traveling uniform motion. But again, this is my braking time. That's the one I'm going to be worried about. This is my reaction time. I'm going to have to add that to the time. This, for all of them, this is the time it takes. This is the delta t complete that I'm looking for. Same with this. This is my delta t. And same with this. This is my delta t. And if I had these stacked on top of each other, these times, these intervals would be exactly the same. So now, once we've got, again, this sort of set up, we can jump into the calculations. And so I have to look at this, and I look at the information that I've got. Let me go back. I know my initial velocity, my final velocity, and my acceleration. So if I want to know the time, all I've got to do is I'm going to have my final velocity is equal to my initial velocity plus a delta t. I'm going to subtract my initial velocity from this side. To get rid of that, I'm going to subtract this from the other side. So I'm going to have my final velocity minus my initial velocity is equal to a delta t. But I'm looking for that, and oh, this is the braking time, by the way. So I've got my acceleration, so I want to divide by that, bring it over to the other side. It will be on the other side, but I'll do the same to the other side. So now I can say that my delta t, my braking time, will be my final velocity minus my initial velocity all over my acceleration. So my final velocity is what? At 27.8 meters per second. My initial velocity is, was it 28? I can't remember if the number was 38.1. 38.1 meters per second. And then I'm going to divide that by my negative. Sorry for the little interruption there. We're subtracting, we're dividing by negative 5.2 meters per second squared. And when I do that calculation, I'll end up with 1.98 seconds. So that's my braking time. So my total time will be my reaction time plus my braking time. So I'm going to have 1.4 seconds to react plus the 1.98 seconds to brake. So I'd have 3.38 seconds, or 3.4 seconds. So we could say, therefore, it would take and just to speed it up, it would take at least 3.4 seconds to get below the speed limit. And that would be our solution to problem 3.